So I get to be here today to sort of set the stage and just get us all on the same page and understanding what it is we're actually talking about when we're talking about sex differences. And when we're talking about sex differences, really all we're doing is acknowledging the statement that women and men are different. Now, when people say this, they mean a lot of different things. When people say women and men are different, they can mean all sorts of stuff. When we say women and men are different, all we're really doing is acknowledging the fact that humans are a sexually dimorphic species. And what this means is that there are two general forms that an adult person can take, two different paths of development to get two different bodies. One of those bodies that is built by and for ovaries, and another body that is built by and for testes. Now, every individual typically developing human has all of the genes, most of the genes they need to build either one of these. Now, if this is what you have, right, you've got both of these sets of genes to build ovaries and build testes. The default form is one where the ovary building genes suppress the testy building genes, and you get the development of ovaries, which then produce ova or eggs, and also produce comparatively massive amounts of estradiol or estrogen, right? Now, if you don't have this, let's say you've got something else, you've got both of these sets of genes, but you also have an SRY gene. The sex determining region of the Y chromosome typically only shows up on Y chromosomes, can occasionally show up other places. I think we're going to hear a little bit more about that later. But if you've got this extra gene, if you've got this SRY gene, what happens is that this gene suppresses the ovary building genes. And so you ultimately get the testes building genes doing their job, which then produces testes, and the testes produce sperm and a whole lot of testosterone, right? Now, this is really important when we're talking about sex differences in general, because this is where a lot of our sex differences start. You notice here that my sort of little graphic for eggs and my little graphic for sperm are vastly different sizes. This isn't even close to the real size difference, by the way. The real size difference is astronomically large. But this is important because this difference in investment in ova versus sperm is really, really big. How big do we mean here? So if we look at bodies that are building eggs versus bodies that are building sperm, there's a huge difference in the amount of sort of energetic investment that has to be put into building either one of those different kinds of gametes. And so we see here that if we look at it in terms of basal metabolic rate, sort of just the amount of energy that your body has to expend just sort of existing, not really doing much else. We see that bodies that are building ovaries and eggs have to expend about 300% of their basal metabolic rate on building those gametes. On the other hand, we've got bodies that are building sperm only have to, and if you consider sperm plus all the ejaculate fluids that have to be there to make the sperm useful, you're getting a basal metabolic rate spent on that of about 0.04%. So if we do that math, what that means is that the energetic cost of gamete biomass production, whether you're building eggs or building sperm, is 3 orders of magnitude higher for females. Again, that really means that females are investing 1,000 times the metabolic energy in producing gametes than males are. That's a big difference, but we're not done there. If we consider just the overall amount of investment that a female has to invest in order to successfully reproduce compared to males, we don't get to stop there, because females don't get to stop there, the amount that they have to invest just to be able to successfully reproduce. So let's say that one of those eggs becomes a viable pregnancy. If you want that female body to take that one pregnancy, say a healthy pregnancy, all the way to term, and let's say you want the kid to survive after that, so you add, say, 6 months of lactation top of that, the metabolic equivalent of that, say the 14 months it takes to gestate and feed offspring, you're looking at the equivalent of running about 60 marathons in 14 months. We're not done yet, though, because once she does all of that, she also then is giving up 100% of her, at least over the short term, 100% of her opportunities for additional mating.
Once she's mated successfully, she can't mate again until some amount of time has passed. So it doesn't matter if she's already successfully mated. If the perfect mate comes along after that, it's useless to her. It doesn't matter. I mean, the absolute perfect mate could come along. If she's already mated, she's done for a while. She can't do anything about it. But we're not done yet, because she also then has to, of course, there is a pregnancy and birth and all of that stuff. She's risking illness and death, right? So this is a lot that she has to invest. Now, males, on the other hand, are almost done with just the building the comparatively cheap sperm that they have to build. I mean, the only really thing you have to do after that is you've got to get the ejaculate where it needs to be. So essentially, he's got to have sex, which estimates say that having sex for men is metabolically about the equivalent of doing light housework. So this means that we can have two people, one man and one woman, looking at the exact same situation, one sexual encounter, one potential sexual encounter. She is literally risking death. He is risking the equivalent of, a couple minutes doing the dishes, maybe vacuuming if he's like really into it, right? So this really means that women and men are different. Women and men are different. Say, okay, so that's what it takes for reproduction. But what does that get us, say, in down the road differences, right? We know those bodies have to be different in order to create those differences, right? So we can look at, say, differences in, say, some basic biometric features between men and women. And look at the size difference here. If we look at post-pubertal testosterone levels, remember, testosterone produced by those testes that only people generally with the SRY gene have, that this size difference, if we look at, say, a Cohen's D score, that's 16.6. That's huge. We generally put the cap at calling something a large difference at 0.08. So 16.6 is just astronomical. That means if you look at the general population of humanity and you randomly select one man and randomly select one woman from the general population of humanity, there is 100% chance that he's got a higher testosterone level than her. On the other hand, if you look at estrogen levels, there's almost 100% chance that she is going to have a higher estrogen level than him. He's also substantially more likely to have more muscle mass and to be taller. Now, okay, fine, but let's also consider the fact that testosterone is a performance-enhancing drug. So then we would expect that men and women would be different on metrics of performance. And we see exactly that there are huge differences between men and women on some metrics of, say, athletic performance. If we, again, randomly select one typically developing man and randomly select one typically developing woman from the general population of humanity, what we've got is that he's got about a 97% chance of having a higher hand grip strength than her. There's also a greater than 90% chance that he's going to be able to throw a ball farther than her and harder than her. Now, there is a substantial chance that she's actually going to be more resistant to muscle fatigue than he is, which is probably one of the reasons why we see women performing comparatively well in, say, endurance sports. But let's say we've got a woman who doesn't like that idea, Dr. Tucker. And so we have a woman who's determined to become as strong as a man. She wants to be as strong as possible. Can she do it? If she really, really, really works hard, if she absolutely does everything she can to be as strong as a man, can she do it? I'm sorry, Dr. Tartar, you cannot. So if we say take one general population man, right, and then we select at random one elite female athlete, a woman who has spent her entire life dedicating herself to being as big and strong and as athletic as possible, there's still a huge difference there. So if we compare that one average randomly selected male and one elite female athlete, there's still a greater than 80% chance that he's going to have a greater hand grip strength than her. In fact, greater than 90% of men are going to be stronger in terms of hand grip strength than the average elite female athlete. And let's say we take the absolute strongest elite female athlete that we have, right? She's still only going to be about as strong as the average man. And if you want to see what this looks like in real life, I'd suggest talking to Dr. Brager over here, who, again, in addition to being a neuroscientist and a major in the Army, is herself an elite female athlete who has relatively recently completed the Army combat fitness test and scored essentially as high as it is physically possible for a woman to perform. And as a consequence of that, she gets to be recognized as an average soldier. Yeah, boo to that, I know. Okay, so what if we take that somewhere beyond just a physical body, right? I mean, could we have some of these sex differences in basic sort of metabolic differences and the performance differences? Are there going to be some other psychological differences, some other behavioral differences? Well, one place we would expect to see that, I mean, given the whole any one sexual encounter, she's risking death, he's risking doing the dishes, we would expect to see some differences in what men and women look for in a potential mate. Now, there's lots of things that people look for in a potential mate, and everybody wants somebody who's nice and kind and all that, and that's great. But we do see some substantial sex differences in some of these variables. So we see if you, again, select one randomly selected woman and one randomly selected man from the general population of humanity, you see that she is substantially more likely, when looking for a potential mate, to care about his earning potential, his ambition, whereas he is moderately more likely to care about how physically attractive she is. Now, I'm not going to say much more on this because if I start talking about it, I won't stop for 3 days. So I'm going to leave that there. But what I will do is move on and acknowledge the fact that not everybody isn't one thing, right? We're not just one variable. We're not just our earning potential or just our ambition. We are lots of things. So David Buss has originally identified 19 different traits along which men and women look for different things in a potential partner. And so what happens if we look at all of these differences together? So instead of taking a univariate approach and just looking at one variable or another, we take a multivariate approach and look at, say, pattern differences. Are there sex differences in the patterns with which people look for any of these traits in a potential partner? Huge differences. So if we look at the overall pattern of differences, we take this multivariate approach, look at the overall pattern of differences and what someone looks for in a potential mate, we see only a 22.8% overlap in what men and women look for overall in a potential mate, which again is not surprising considering she's risking death and he's not. Now, we also can do the math here and we can use this and say that if we take all of this that we know about someone's mate preferences, and if we only know that about them, say we pick a random person out of the general population and we know absolutely nothing about that person except what they look for in a potential mate, we can predict that person's sex with greater than 92% accuracy. We can't predict anything with 92% accuracy. Imagine if we could predict the weather with 92% accuracy, what we'd be able to do. These are huge differences. Okay, fine, it's directly related to mating, so of course we'd expect to see some differences there, but what happens if we take it a little further back? Take another step away from basic biology. Let's talk about personality differences. Now again, when we look at individual univariate measures, we look at one metric at a time, we do see some differences here. You again take one randomly selected man and one randomly selected woman from the general population of humanity. You see that she's substantially more likely to demonstrate sensitivity, be more sensitive as a person. She's moderately more likely to be more apprehensive, maybe score a little on warmth. He's slightly more likely to score higher on measures of dominance or privacy, negligible differences beyond that. But if you, again, take a multivariate approach and look at the sum total of a person's personality measures, we only see a 10% overlap between men and women. There's only a 10% overlap between men and women on global measures of personality. Okay, fine. But maybe there's some practical differences. Does this extend to something practical? Well, okay, let's look at, say, vocational interests. Does maybe this have some relationship to what kind of job a person wants to take? Seems that there might be, right? So we have, say, again, one randomly selected man, one randomly selected woman from the general population of humanity. We see that he is substantially more likely to be interested in doing a job that involves doing things, a kind of hands-on job. He is also slightly more likely to be interested in a job that involves thinking, organizing, persuading people, think lawyer. She's slightly more likely to be interested in a job that involves helping people. Overall, she's substantially more likely to be interested in a job that is people-oriented. That is not me. I don't like people. But again, if we look at the global perspective here in terms of vocational interests, we again only see a 27% overlap between men and women in terms of what kinds of jobs they're interested in. But maybe there's something beyond this, right? Well, let's say we take one man and one woman and put them in the same job. They get to the same job, right? And for fun, let's make it a job where physical size and strength is wholly irrelevant to any of it. Let's say, I don't know, university faculty member. Are there maybe differences in the actual work that men and women are doing while in that ostensibly same job? Seems that there is. Women are moderately more likely. So if you have one male faculty member, one female faculty member in the same job, she's moderately more likely to have been asked to take on additional work that week compared to him. She's more likely, slightly more likely to spend more time mentoring student research. She's more likely greater number of student research projects to mentor, whereas he is slightly to moderately more likely to be spending time advancing his own research. So it seems that even when we have men and women in the same job, they're not necessarily actually doing the same job. Okay, fine. But I mean, would we expect that to maybe translate to, say, differences on a practical level in terms of, I don't know, compensation? Seems so. That if you take sort of a variety of different jobs that men and women could engage in with the same degree and the same vocation, it seems that generally across the board, he is more likely to get paid more than her. Okay, fine. There could be an argument that maybe he's just better at it. So maybe men are just better at jobs, and so that's where this increase in likelihood of getting higher compensation comes from. So we can, in fact, look at, are there sex differences in job performance? Okay, so again, let's stick with a job where physical size and strength is irrelevant, but let's move away from university faculty here and say go to physicians. So what if we look at physicians and compare male physicians to female physicians in terms of their performance on the job and how much they're likely to get paid? Now, generally, there's not huge differences here between how male physicians perform and how female physicians perform. She is moderately more likely to score better on some practical assessments of physician fitness to practice. Not really any difference in terms of, say, physician knowledge tests. He is nominally more likely to have patients die or readmitted into the hospital, but he is slightly more likely to get paid more than her. It has been argued that one of the reasons that we see the sex difference in pay when we don't see sex differences in performance, because she seems to be busy outside of work. If you just look at, say, married female physicians, you see that she is, compared to him, the other male married physician, she's more likely to have additional, say, household duties compared to him. So it seems that men and women are not necessarily doing the same jobs or getting compensated for the same jobs in a variety of different fields. So, okay, this is all fine, everything. But when I started, I promised I was going to talk about what sexual dimorphism in humans is, what it is, what it isn't, and why it matters. So I hope I've at least started to get us there. But just to sum up, in case I didn't do my job well, what it is, sexual dimorphism in humans is a consequence of evolutionary pressures that results in biologically based differences of various effect sizes in a wide range of physiological, psychological, and behavioral variables between people who live in bodies that have been masculinized and people who live in bodies that have not been or have been less masculinized. That's what it is. What it isn't is simple. It's not a simple thing. When we say men and women are different, people want there to be a sweeping statement about that. It's not a simple thing. It's also not a value judgment, which is the other thing that people tend to think it is. When we say that men and women are different, we are not saying men or women are better. We're saying that they're different. If we decide to treat them differently or value them differently, that's a different decision that we're making. That's not just what sex differences are. That's a whole nother decision that we've decided to make, and why it matters. I mean, just think about everything That does matter. Think about every medical treatment, every law, every policy, every institutional practice that could be relevant to these things that we're talking about here. That's why it matters. So it's important to all of us for people to continue to do this kind of research, to really start to better understand what it is that we're talking about when we're talking about sex differences. And we're going to have some of those very talented researchers come up here and tell us a little bit more about these sex differences as soon as I stop talking. So to that end, thank you very much. And on to the next. Questions? Yeah. No, that's sum total. So that's sum total, a body that builds eggs versus a body that builds sperm. How much of that basal metabolic rate is contributing to building just those gametes? Doesn't have to do with anything else. It's just the gametes themselves, just the eggs, just the sperm, or in the case of men, sperm plus all the ejaculate fluid and everything that requires to make that sperm valuable. Yes. Thank you. Mm-hmm. So it's a good question. We don't know quite as much about non-heterosexual relationships and preferences as we do heterosexual relationships and preferences. But really, we get back to the idea of the extent to which the body that has those preferences has been masculinized. That's really what it gets down to. So when you have a body that has been masculinized, you have a body that hasn't been masculinized. That's really where we start to see those big differences. And we do tend to see that there are basic hormonal differences generally between people who identify as heterosexual and people who identify as non-heterosexual. But that does bring me to one other point that may be relevant here that I didn't have time to talk about. But when I talk about masculinization, there's actually two different ways that a body can be masculinized. There's the physique, the actual physical form, what you see when you look at a person. But then we also have neural masculinization. It actually is a different critical period. So when you get masculinization of a physical body, that happens at a separate time in development compared to masculinization of the brain, which is really the seat of all these preferences that we're talking about. So that would make a difference too. I know I sort of side-skirted your question, but thanks for letting me do that. Yeah. Oh, I'm sorry. My apologies. So this question was about, hopefully you got the gist of the question from my answer to it, about the differences between heterosexual versus non-heterosexual mate preferences. And the first question was about the metabolic sex differences in gamete production, sort of whether that's just during a certain time or sort of a global difference. Okay. No, the statistics that I showed were controlling for all variables relevant to that. So controlling for specialty, controlling for baseline patient health metrics, all of those things. Damn it. Sorry. The question was, if you're looking at, say, male and female physicians, would it make a difference in terms of the particular specializations, the specific specialties that male or female physicians take on? Can I be done now, or are there more questions? I'd like to be done now. No, we're good?